Hi, and welcome to this Freeform version 2025 feature video discussing Perforate. Perforate is one of the new tools in version 2025, and it's designed to, well, perforate or create small holes in your model. You can find it in the Detail Clay palette. It's the last item in the palette. This model that we're looking at right now is a scan of a person's lower limb that requires a prosthetic. Inside the prosthetic, people will have a liner that is meant to provide comfort and traction, so we need to create something that is going to cover this region as well as have some holes in it so it's breathable and comfortable. The tool provides several different ways of selecting where you want to perforate your model, so you can paint your selection. There's curve selections, these are curve loops. There's a seed point selection tool which coincides and works with the curve loop selection, or you can select existing points which are annotation points already created in Freeform. Right now, this is not exactly what we're looking for, and trying to paint a complex selection is a little challenging, so oftentimes you will use a combination of tools to do this. I already have a selection made that I'm going to recall. And let's take a look at what this tool does. I'll click Preview. We get a status bar at the bottom. And now we have a preview of the perforations that are going to be created on this model. These are circles. They're spaced out pretty evenly across this region. And this solid mode is going to tell me how this is going to perforate. Hollow mode is going to shell the model and create holes in the regions that are previewed. Or we have a divot mode, which is going to create basically embossed areas where the preview circles are, and it's not going to perform any type of hollowing or shelling operation. So for the hollow, this is going to create a 10 millimeter thick model, and I'll click Apply. It looks like it did exactly what we told it to, but that's not the goal for this design. I'm going to undo. And many times when you want to create your perforations, you already have your model, or at least the liner portion of your model created. I have one right here. And if I hide the scan, you can see that this has been already shelled. It has everything we need. We just need to put the perforations onto it. Painting a selection isn't the best choice because it paints through the model and it's going to try to perforate from both sides. So using curve loops is going to be the best choice here. I'll clear my painted selection and turn on one of my curve loops that I've already created. That is just a fit curve that goes around the outside upper collar. Switch to curve mode, select my curve, and then select my seed point, which is going to be the area on the outside of the model below that curve. Not bad. You can see that the perforations are fairly well distributed. There's a couple that don't look entirely right. We do have a lot of extra options in the Perforate Settings dialog, so we can change the diameter, we can change the distance between the perforations. The margin is how close they are to the edge of the selection, smoothing around the border, or we can enforce minimum spacing. So if I turn this on, and I believe I have to turn this up a little bit, but this will ensure that there's a minimum of 8 millimeters between the center of each of those perforations. Now if I choose divot and my amount is greater than the thickness of this part, when I click Apply, it should punch holes right through it. Excellent. That is just what I was hoping for. I'm going to undo because we have some additional options that make this even more powerful and give you a lot more control over how these points are distributed. If I turn on my lower curve, this here is a circular curve that was projected from a sketch. I can select both of these and set a seed point on the surface between them, and now it's only going to place perforations inside that region. This is very important because this is also going to give me margin control. So if I turn up the margin to something like 3 millimeters, it's going to have a minimum distance from the edges that it's not going to place a perforation. We also have something, actually I will clear this, because we have another mode which I haven't discussed, which is our distribution. Right now, equal triangulation is using the triangulation of the surface model and trying to make it cover that in a fairly uniform way. We have something that's called UV projection, so this is going to try to unwrap and flatten the selected region, and this often provides much more uniform and consistent results, but it has a couple limitations to how it can be created. Right now, this being a fully cylindrical type of shape, there is no way to flatten this out and have something that can be mapped to a flat object. So, we have the choices of either defining certain regions, such as a singular curve loop. And this doesn't have to be a single curve. This could be a collection of curves. So I could have a set of 3, 4, 5, however many curves. But with this, if I change this, actually, let's see what equal triangulation looks like first. And now I will turn on UV projection. The difference is a little hard to tell, just because they're spaced a bit far apart. So if I bring them a little bit closer together, you can see now that they are appearing in a row. If I set my angle to 0, they are in a grid. I can change the grid from a regular grid to alternating, or even hexagonal. So it changes the properties of how they're distributed, how it's calculated. And because this is a regular shape that if you were looking from one direction and you could imagine this being flattened, that is how it's achieving this type of result. You can take a model like this and create a seam. So I'm just going to do this with a fit curve. And now, because we have a seam in this, you can imagine if the cylindrical shape were cut along this line and then rolled flat, this is how it would project. So, switch over to curve selection mode. And now preview. Change from equal triangulation to UV projection. You can see that this covers the surface in a much more regular distribution, but it does get a little off as it tries to wrap all the way around to the back. So this may work better in some situations than others, but knowing that this is available, you can design accordingly, and you can end up with spectacular looking results without having to create all of those perforations yourself. Thanks for watching.